Hi guys, in this recording we're going to talk about types of chemical reactions. So we're going to start off with two of the easiest ones. The first one is a synthesis reaction. And this goes along with what we know the word synthesis or synthesize to mean. It means to make something new. So here we're using symbolic letters to represent that anything off of the periodic table can be used. So what we're saying here is that we have one atom of an element being represented by A, and one atom of an element being represented by X, and they come together or synthesize a new molecule of AX. And here we see that if we have a sodium and chlorine come together, and there are two chlorines together because remember chlorine is a diatom, so it doesn't hang out by itself, then we're going to end up with the new molecule of sodium chloride being synthesized. Hi guys, so here we're talking about decomposition, which is another word that we're pretty familiar with because we talk about things decomposing, especially in biology. And here we can have a molecule decompose into the two or three or four, depending on how many elements are there, into their separate parts. So we have things bonded together and they break down into individual parts. And here we have an example of we are heating up what looks like some copper 2 carbonate, and that is producing copper 2 oxide and carbon dioxide. So we're taking one thing, heating it up so that it breaks down into those two separate parts. And a side note, our heat here is a catalyst. All right, let's go to our next reaction type. Our next reaction type is called a single replacement. And this is where we have a single element on its own, represented here by an A, and it comes in contact with a molecule represented here by B and X. So B would represent the cation and X would represent the anion. And they collide and we produce a new molecule where A bumps off cation B and forms with the anion. So A and B are both cations and X is an anion, and they have switched what cation or metal is bonded to the nonmetal in this situation. And so my analogy here is it's like B and X are a couple, right? They're connected together and they run into A, and X finds A more interesting and literally more attractive, chemistry pun. And so X bonds with A and B becomes a solo partner. This happens because of electronegativity. So B has less electronegativity to A, and therefore X is more attracted to them there. And that likely occurs because of greater nuclear charge, more protons in the center, and less electron shielding, right? Connecting it back to that prior information. So here we see when we take an iron nail and we put it in some copper 2 sulfate, we will end up with copper being replaced by the iron. And so copper will end up on the iron, and iron will leave the nail and go and be with the sulfate. And so we will end up with iron 2 sulfate. All right, let's take a look at our next type of reaction. Here we have a double replacement. This is where we have two molecules and they swap partners. My analogy here would be like if one friend, let's call Amy, right? So let's say Amy is wearing a sweater and she runs into her friend Thelma, And Thelma has on a sweater also, and they both love each other's sweaters. So the next day, they swap sweaters, and Amy's wearing Thelma's sweater, and Thelma is wearing Amy's sweater. So this would be like two friends swapping clothing. Whereas a single replacement would be like Amy putting on a shirt and saying, I don't like the shirt, and going back to her closet and changing shirts and hanging that shirt she had on back up or throwing it in the laundry or whatever. So a double displacement is where you have two molecules and they're swapping cations and anions with each other. So here we see that copper 2 sulfate again. Over in this beaker, we have sodium hydroxide. And when we bring the two together, we end up with copper 2 hydroxide and sodium sulfate. So they have swapped those cations there. Double replacement reactions can also, there's a specific type of double replacement reaction called a neutralization reaction. And it still falls under that double displacement or replacement reaction, except it's where we have an acid and a base. And we often represent an acid as having a hydrogen on it and a base as having a hydroxide. So the A here in the acid is representing any element that could have a hydrogen on it, like a chlorine or a fluorine or a bromide. Here the B is representing anything that could have a hydroxide on it, so like a sodium or a potassium. And we see where those placements are. So the A is going to be a nonmetal, and the B is going to be a metal or a cation. And when these two come together, A and B are attracted to each other, and another product is water. So here we see hydrochloric acid, and in the other dish we have sodium hydroxide, and when we bring together, we end up with the salt of sodium chloride and water as our product. So this neutralization reactions are a type of double displacement that include acids and bases. And here's some other examples of acid and base neutralizations for you to take a look at. And we even have one here where there's some balancing involved. So nice examples there. Our last type of reaction is a combustion reaction. And the reason that we save it for last is they are the hardest to balance because you have oxygen in two different places in the product. And one has an even number of oxygens and one has an odd number of oxygens. So what is a combustion reaction really? I mean, obviously we associate a production of light and heat with it, you know, fireworks, campfire, things exploding, or Bunsen burners, right? These are all combustion reactions. But what a combustion reaction really is it's a hydrocarbon. So what that means is carbons with hydrogens attached to them. And there can be other things involved too, but it's a chain of carbons with hydrogens attached in different ratios. So here we're looking at methane, which is 1 carbon and 4 hydrogens. And it's always in the presence of oxygen, right? If we take a candle and we remove the oxygen, that candle can't combust anymore. And the products are always carbon dioxide and water. And then we balance it out so that we have as many atoms as everything on one side, and the reactant side also being represented in the product side. So let's look at some examples. So here we can see basic carbon and oxygen coming together to produce carbon dioxide. We see we have propane, which is 3 carbons with 8 hydrogens. So we'll need 5 oxygens, and it will produce 3 carbon dioxides and 4 waters. Here we have methanol, which is 1 carbon and 3 hydrogens, but also has an OH there. Let me draw that for you so that you can see that. So we have carbon and we're going to have a hydrogen. Pardon me, I'm using my mouse to do this. I forgot my little electronic pad thing to make this easier. And we have an oxygen, and remember that oxygens form bent molecules there, so that because of those lone pairs, so it's going to be at that little angle there. So there's our methanol. That all ending tells us that that OH is there. And here we have an acetone, which has an oxygen, but that oxygen is attached to the carbon, not to the hydrogens. So it's actually attached to the central carbon there. So let's see, carbon, whew, this is hard to do with a mouse. Okay, and then we've got our 3 hydrogens there, and our 3 hydrogens there. And then off the center, we have a double bonded oxygen with its 2 lone pairs up there, so that this carbon has its 4 bonds, or octet rule, and then those lone pairs. These lines here are all hydrogen bonds. I'm just not writing in all those H's because it's a lot of work. Can't lie there. Okay, good? All right. How to identify reaction types by looking at the reactants. If you see 2 elements, meaning 2 reactants, then that is going to be a synthesis reaction. If you have 1 compound in the reactants, then that means that's going to be a decomposition reaction. If you have 1 element and 1 compound, that's going to be single displacement. If you have 2 compounds on the reactant side, that's going to be double displacement. And if you have a hydrocarbon in the presence of oxygen, that's going to be a combustion reaction. All right, guys, here's identifying reaction types practice. Please pause the video and give this a try. Write it down in your notes. Okay, so the first one is a synthesis. The second one's a decomposition. Third is single displacement. Fourth is decomposition. That's a sad looking D. The next one is single displacement. Next is a double displacement. The second to last is a double displacement, but specifically a neutralization. Notice we have the OH and the H, and we formed a salt. How you know it's a salt is it's an ionic bond, and we have water. And the last one is a combustion reaction with hydrocarbons in the presence of oxygen producing carbon dioxide and water. All right, let's look at transforming word equations into chemical equations. So here our example is sodium metal is added to water, hydrogen gas bubbles off, and sodium hydroxide is left behind in a solution. So go ahead and pause, write the balanced chemical equation and what type of reaction it is. All right, so here we have our answer. We have sodium metal, which is a solid, added to liquid water, and it produces hydrogen gas that is being bubbled off. So we have our arrow up there, and producing sodium hydroxide, which sodium's a +1, hydroxide's a -1, so it's a 1-to-1, and it says in solution, so it's aqueous. We then had to balance our equation so that we have 4 hydrogens over here, and we have 2 hydrogens here and 2 hydrogens here for a total of 4 on the product side. It also gives us 2 oxygens on the product side and 2 oxygens on the reactant side, and 2 sodiums, so we had to come over and put a 2 here. Notice that we only changed the coefficients, which I have written in this pinkish mauve color. And this type of reaction is a single displacement. So sodium is displacing a hydrogen, and we're getting hydrogen leaving, and sodium hydroxide, yeah, those guys are still there, but that's okay. All right, let's look at our last example here before we go to some practice outside. We have an aqueous solution of potassium iodine and silver nitrate are mixed and form potassium nitrate and a precipitate of silver iodide. Pause the video and give it a try yourself. Okay, so here we are with potassium iodine. Potassium's a +1, iodine's a -1, so 1-to-1 ratio in solution. Silver is a +1, nitrate, notice we have the polyatomic ion there, is a -1, so 1-to-1 ratio in solution. Will result in potassium nitrate, still a 1-to-1. Potassium's a +1, nitrate's a -1. And that is in solution, but our silver iodide tells us that it precipitates out, so that means we've got our arrow down. That's kind of a lame arrow there. Arrow down, and so it's going to be a solid. I'm going to look back and make sure that my equation's balanced, and it looks like it is. So there we go. All right. That's it for types of chemical equations in this video. Check to see what other practice you have.